in a particular.
I'm recording.
Yeah, thank you. You're trying to study the traffic level in a particular locality, maybe particular area, and you are just doing a survey for about 3 months, right? Doing a survey. What will you do? You just check how many vehicles are going every single minute, how many vehicles are going every hour, what kind of vehicles are going, who is driving, and all those information you are collecting. You are collecting a data, and you did this study for a period of over a period, let's say 3 months. And now you make conclusion like this. On an average, there are 3,000 vehicles are crossing that particular point, particularly during the peak hour. How do you know? Because you collected data. This is statistics, right? You are able to describe what is actually happening, isn't it? Now, out of the 3,000 vehicles that has crossed the point, 1,350 of them are passenger cars, and 600 of them are public utility vehicle, and approximately the 1,050 are 2 and 3 wheeler. What is this? This is statistics, isn't it? So you collected the data, you had a survey form, data collection, you call it check sheet or something. You collected the data, you tabulated it, and then you visualized it. You have presented it in a readable format, and then you interpreted it, and you came out with this kind of conclusion. This is what is called statistics. So what is statistics? Statistics is the science of collecting, organizing, presenting, analyzing, and interpreting data to assist in making more effective decisions. When you do this correctly, your decisions can sound very good in the organization. This is statistics. And the collection of numerical information is called statistics. All this information, this is what I told you so far, right? 3,000 vehicles, 40% of them are passenger car, and 20% of them are public utility vehicle, and another 35% of them are 2 and 3 wheeler, right? And likewise, you can make beautiful statements. An automobile in US, on an average, it travels 11,099 miles every single year, right? So you get an idea. There are several business can rely on the running of the vehicle, isn't it? The service center and many things you can plan with when this information is available, right? Similarly, a bus travels about 9,300 miles per hour. A truck travels about 14,000 miles per hour. And that's the same situation in Canada. So now you are able to compare Canada and then US in terms of the movement of the vehicle. This is called statistics, right? And in your organization, the mean waiting time to receive technical support is 17 minutes. Every time customer raises a ticket, or every time customer makes your call center, on an average, they are made to wait for about 17 minutes. This is statistics, isn't it? So you get an idea of what is actually happening, and through the data only. And now for the statistics, there are different applications, different uses. First use, you can always summarize your data with the central values. For example, I conduct an examination for all of you. How do I understand the effectiveness of the training program? I look at the average performance, average mark scored by all of you, isn't it? Individually, 1 or 2 students might score very high mark. 1 or 2 students might score 0 mark. It doesn't reflect the effectiveness of the program. But which will definitely reflect the effectiveness of the program? The central value. What is central value? I calculate average out of all your marks. Looks logical, isn't it? So central tendency, whether it is mean or median or mode, will help you to summarize the information. It is only through these kind of statistical values you will be able to speak to the data. Otherwise, data will just be a data, and you understand nothing out of it. You have crores of data, but how do you understand the information that is coming from your data? By calculating certain statistics, right? And certain statistics will talk about the central value. Certain statistics will talk about the degree of variation that exists in your data. The degree of variation can be calculated using standard deviation, range, or variance, right? And finally, you can also use the data to explore or to understand the difference that may exist between group. How this particular batch 12 black belt are performing with respect to the batch 11 black belt. I wanted to understand the improvement in the impact of the training program. The impact we made in batch 11 and the impact we made in batch 12, I want to know. How do I know? I will compare your statistics with the previous batch statistics. Your statistics are nothing but the central value and the variation. What is your class average? What is your class standard deviation? Similarly, what is the previous batch class average, previous batch standard deviation? So statistics can also help me to study and understand the difference between two groups, difference between two companies, difference between two products, difference between two segment of customers. I can use it, right? But here comes the difference. You know, you will be able to appreciate, you will appreciate the difference if the difference is significantly large, isn't it? For example, one student has scored 60 marks, other students have scored 62 marks. In my opinion, both of them are average performers. I really do not differentiate one, from the other, because the difference is small. When the difference is small, we don't consider the difference as significant. But when the difference is large, one student has scored 60, the other students have scored 85. I will definitely appreciate the student who has scored 85, because 85 is, definitely, significantly higher than 60. So he really deserves appreciation. But 62 from 60, sometimes it is maybe completely, due to a random chance, right? So it is the significance that is used to understand the difference that may exist between two groups. See here, I have about 10 or 12 data here. What is this data is telling? The data may be characteristics of a product. Maybe, my product is, maybe a garment, or my product is student's test mark, whatever it is. For me, it is just a number. I have 12 number. In order to understand the information that is hidden in this data, I will calculate certain statistics. See here, n equal to 12. What does it mean? There are 12 data points.
Observations.
There are 12 data points and no missing data. Continuously data is collected in every shift. No missing data. Mean, you know what is mean? To add all the value, you get the mean. Standard error of mean. Standard error of mean will help you to identify your confidence interval on the mean. Standard error of the mean helps you to identify the confidence interval on the mean. For example, if the average is 3.833, when I run the process again, what will be the average again? Will the average be same? But definitely between the range. Definitely I will say that again the average is going to be between I will say between 3 and 6, or between 2. I will say the average will be between 2 and 6. Because the average is 3.833 now, when you run the process again, the average is going to be definitely between 2 and 6, because it is 4 here. Now the 2 and 6 are called the confidence interval. How do I get the 2 and 6? Using this value only, standard error of mean. We'll talk about it. Trimmed mean. What is trimming? Trimming in garment industry is cutting. Same way, 3.833. When you cut it, it will become 3.5. Standard deviation, you all know. Variance, square of standard deviation. Summation, simply add all the number. Minimum, which is the minimum you are seeing here? 1. That is coming here. And maximum, 10. The difference between minimum and maximum, that is called the range. Now quartile 1, what is quartile 1? A point below which at least you have 25% of the value, 25% of the data. What is quartile 1 here? 2.25. How many values are below 2.25? Can you tell me here, looking at the thing? How many values are below 2.25?
2.
Check again.
3.
3 value. What is 3 out of 12?
25.
So quartile helps you to understand the 25% of the data below the quartile 1. Similarly, 50% of the data will be below quartile 2. Quartile 2 is otherwise called as median. Below quartile 3, there will be 75% of the data. So every statistics gives some information. Use all the. Finally, your decision have to be more effective and meaningful, right? And then interquartile range. What is interquartile range? The difference between Q3 and Q1. Difference between Q3 and Q1. Q3 is how much? 4.75. Q1 is how much? 2.25. The difference is how much? Correct? 2.5. And then mode. What is the mode here?
3.
3 is occurring frequently. So 3 is the mode. How many times it occurred?
4 times.
4 times.
This now I described the data. Valentine's Day, you describe about your wife and your girlfriend, isn't it? Same way. So I described the data. This is called descriptive statistics, right? So then the formula, standard error of the mean formula, standard deviation divided by root of n. I should have used small n here, But anyway, no worries. Standard deviation divided by root of n. What was the standard deviation? You know, it is how much? 2.368. The same data that is used for calculating the mean is used to calculate the standard deviation. That standard deviation divided by n. What is n here? 12. Now you got the standard error of mean. Whatever value it comes, it's already listed here. Standard error of mean, 0.683. Very good. And quartile 1, these are the formulas. Maybe you can go through it. So this manual method also there, mini-tab method also there, whichever is convenient. So you have quartile 1, you have quartile 3, you have interquartile range. And when you visualize, when you draw a box plot, you quickly get an idea about where is your quartile 1, where is your quartile 2, and where is your quartile 3. The center line is the quartile line, and that is also called median. So what is this line? Quartile 2, right? And what is this line? Also known as median. All right. And this diagram is called what?
Box plot.
And this line is called what? Whisker. What is whisker, not whiskey.
Whisker.
Right. So not the quarter and whiskey. These are quartiles and right. And you see one point is far away from the center value. This is now considered an outlier. What is that number? 10. When every number is around your central tendency, the 10 is far away. So that is now considered an outlier. Always outliers should be excluded in your analysis, except MSA. Except MSA, always your outlier should be excluded. Right. So descriptive statistics and inferential statistics. You did a study, you are able to describe the problem the people are facing in that locality. So what is your statistics now? Descriptive statistics. And now you using the descriptive statistics, you are suggesting, for a flyover construction. Now, when the flyover is constructed, what will be the benefit? How many people will get benefited? How do you know? You only studied the past. Will you be able to judge on the number of people who are going to be benefited? Yes. If you do the study properly, you not only understand the present and past, you will also be able to understand the future. That is called inferential statistics. Right? Use the data to understand the present and the past. What is that? Descriptive. Use the same data to understand the future. That is called what? Inferential statistics. Use a sample to describe a population. That is descriptive statistics. Use a sample to understand the characteristics of the population. That is inferential. Hope all of you understood the difference between descriptive and inferential statistics, right? So all these statements, by reading the statement, you can simply classify whether it is descriptive or inferential, right? And then our passing rate is, our pass percentage in practical program is 95%. What is this? Descriptive or inferential? Our passing percentage is 95%. What is it?
Descriptive.
Beautiful. And what percentage of students I can expect to pass from this particular batch? 100% can I expect? That is inferential, right? But you don't want to comment on the percentage, right? So one, the other one is inferential, right? I'm not going to read out all the statement. Now you have become a master. You can read out all these things, right? Fine. So moving on. Now going to the normal distribution. A bell-shaped distribution. Most of the characteristics of natural process, any process which is natural. For example, if I conduct an examination in a fair manner, your exam marks will also follow normal distribution. But when I leak out the question paper, all of you will score between 80 and 90. Then it may not be normal, isn't it? So generally, natural process will follow the normal distribution. Then that will look like a bell shape. The mean, median, and mode will all of them will be close to each other. Most of the time they will overlap. The curve is symmetric at the center. Exactly half of the value are to the left of the center, and exactly half of the value are to the right. The total area under the curve is considered 1. Maximum value is 1. Do you all understand all the 4 properties? All of you understand? Yes?
Yes, sir.
Very good. You can also observe the same thing in the graph. You can plot a graph if you are not trusting my the statements, or if you don't trust the lines written here. Today evening, you collect some data. All of you, you have a meeting. You measure all your height. All of you can share your height in the group, and then try to plot a graph, a histogram, you will be surprised to see an average height. Half of you will be above the average height, half of you will be below the average height, isn't it? And the average height will happen to be at the center. Many people will have the height around the average value only. Am I right? Very few people will have height above 6 feet. Very few people will have height below 5 feet, because we know the average height is around 5 or 5.2. So most of you will have the height between 5 and 5.2. That's why the curve is taller in the center. So symmetrical means right side area is 0.5, left side area is 0.5. That 0.5, which is 50%, will divide like this. First 34% will stay around the average. Am I correct? Majority will stay around average, and then little more will stay in the second zone, brown color, 13.6. What is this first line? 1 sigma. What is this 13.6? Distance between 1 sigma and 2 sigma. What is this last 2.1? 2 sigma and 3 sigma. When you sum up all these things, you are almost close to 50%. Now the rest I don't want to understand, because I don't have energy to go up to infinity. So I will ignore. The remaining is written here. The remaining is beyond 3 sigma. Right? So now the blue color area. What is blue color area? 1 sigma on the right, 1 sigma on the left. What will be the total blue color area? Can somebody sum up and tell me?
68.2.
That is written here. This is also one property of normal distribution. 68.27% of your data will definitely lie within 1 sigma limit. Now, blue and brown total is how much? 95.45. 95.45% of your data will lie within 2 sigma limit. 2 sigma limits are sometimes called as warning limits. If something is happening beyond warning limit, please understand an event having a very low percentage of occurrence is happening. That is why you should care about it. Because what is the percentage for an event to happen inside warning limit? 95%. That is not happening. Something which is having a very few probability, very low probability of less than 5% is actually happening. Then you should be concerned about why such things are happening in your process, isn't it? Always events of higher probability happens in more number. And finally, when I sum up the blue, brown and green, it accounts to 99.73. This point is called control limit. Since the control limit will help you to understand almost everything. All right. Now I have a curve. See here, the curve is divided into two halves exactly at the center. Now I have drawn a line at the center. Now what is the area of the red color region? Or what will be the area of the red color region?
Positive.
Positive.
It's 0.5.
I will say upper control limit.
Total area is always 1. Right? And so 50% on the right side. That is what is written here. So I can now write a statement. Probability of X more than 16.78 is 50% according to this distribution. What is this distribution? Mean equal to 16.78, standard deviation equal to 3, and distribution is normal. Whenever your data is normal, when mean is known, standard deviation is known, and when you see this graph, now I make a statement. Probability of my X variable coming more than or equal to 16.78 is 50%. Do you understand probability? Am I correct? Yes. Now I shift the line. From 16.78, I shift the line to 19.78. Now what will be the probability for me to get a value of 19.78 and above? What will be this probability now? Can anybody explain this now? Let me test your the lower class knowledge. Addition, subtraction. Feel free to make mistake. How this 0.15 came? A plus B equal to 10. A equal to 2. So how much is B?
8.
Simple. This red color area plus white color area, how much you told earlier in the previous slide?
0.5.
Now that area is divided into white and red. And red, white and red. And do you know the value of white? When A equal to 2, B is 8, What is this white color area?
5 minus
0.15 minus 0.15.
Let me go back. The white is nothing but this blue, am I right?
Yes.
So 34%, otherwise 0.341. 1 sigma. Let me check whether it is exactly 1 sigma. 19.8 is at the distance of 1 sigma unit from 16.78. Can you say like that? Because sigma is 3.
T.
So how much will be this value? 0.341
Uh,
T.
yes.
When this is 0.34, right side area is 0.5, what will be the balance?
1.9.
0.15, sir.
You understood probability. So probability of any event to happening can be calculated if you have some little knowledge and understanding about normal distribution. Right now, 20. Earlier I told us 19.78. That is as a multiple of the standard deviation. Job become easier for you. But when I make it 20, it's a real tough problem. I know all of you have solved this kind of problem in your 11th standard. But then you have forgotten, right? You just have to recall. And that is what is taken care in Minitab and Excel and all those things. For every value, there is something called G score, Z score. If you calculate the Z score, finding the probability becomes easier. Suppose if you are at 16.78, what is the probability you told? 50%. Very easy. What is the Z score at? If see, 16.78 is the population mean. Population mean is 16.78. Sample mean also 16.78. Now I want to know the Z score. Z score is nothing but sample average minus population average divided by standard deviation. What is sample average? 16.78. What is population average? 16.78. How much is the difference?
0.
0. Divided by standard deviation. You divide 0 by any value, that will be again 0. When Z equal to 0, you can understand you are at the center. So you are under target. This is what you want to achieve. But this is what your process is giving. But you understand from the process average, you understood your result equal to 0. That means your process is centered on the target. When Z equal to 0, what is the area to the right side of Z equal to 0? 0.5. When you calculate the probability in terms of X variable, it is a normal distribution knowledge. When you calculate probability in terms of the Z variable, that is called standard normal distribution. For a mean value of 16.78 is converted into 0. In reality, no average can be 0. Am I correct? In reality, average cannot be 0. But we convert this mean value to another number called Z variable, but we made it to become 0. Right? So any variable, any problem in your factory can be converted into a Z value. And there is a probability for each and every Z value. When Z equal to 0, right side probability is 0.5. Left side probability is 0.5. And now, what will be the Z value here? Can somebody tell me? What will be the Z value for 19.78? Here it is 0, I said. Here the value will be, what is the difference?
1, sir.
Ah, beautiful. Here it is 19.78. Here it is 16.78. What is the difference?
3.
3.
Divide the difference by standard deviation. Now what will be the Z value?
1.
When Z becomes 1, what happens to your probability? Probability goes down. As the Z keeps on increasing, the probability of Z beyond the observed, the probability of Z value beyond the observed value keeps on decreasing, isn't it? You get some idea. So this is what is summarized. So probability of X more than 16.78 equal to 0.5. If you understand the probability, then probability of Z more than 0 is also equal to 0.5. Right? Probability of X, X less than 16.78. That is also 0.5. You can appreciate that.
Sir, this 0.5 we did it, for the equal to X is equal to 16.78, right?
No, not equal to. Probability at the point is 0. Suppose when I say your pass, you will pass only when you score 82 mark. Will you be able to score exactly 82 mark?
No, more than that.
Always, probability can be calculated only between two values. You cannot calculate probability at a single point. Probability at a point is theoretically 0. You may be knowledgeable. Still, when I say you should score exactly 82 to pass, then you are going to fail. Isn't it? So, Now probability between 13.78 and 19.78. How much this will be? Anybody make a guess? 13.78 means 1 standard deviation on the left. And are you with me?
Yes, sir.
19.78 also 1 standard deviation. So what will be the area within 1 standard deviation plus or
0.687.
68.27. I am wrong here. Irrelevant number here. 68.27, or I can call it 0.6873. Hope this slide is very clear to all of you. Now I replace X variable into Z variable. What is the conversion formula? The observed value minus target value. What is your target?
16.7.
Population. No, the target is always the population value. Observed value is always the sample value. The difference between the sample value and the target value divided by the error. That is nothing but standard deviation. Sometimes error is standard error of mean. Standard deviation, when to use standard error of mean, you will learn in the due course of time. Otherwise, everything else is same. Do you now understand the difference between normal distribution and standard normal distribution? Normal distribution, center value can be any value. But in standard normal distribution, what is the center value?
0.
That means mean is replaced by 0. And then here 1, 2, 3 is written. Earlier 1 sigma, 2 sigma, 3 sigma was written. Now 1, 2, 3 is written. Now standard deviation is replaced by 1. When I make sigma equal to 1, this will be 1 sigma is 1, 2 sigma is 2, 3 sigma is 3. How many of you understand? So distribution is standard normal distribution. When mean equal to 0, standard deviation equal to 1. Is it clear?
Yes, sir.
Everything else is same. Now I want all of you to understand 3 distribution exists. One is population distribution. What is population distribution? So far, we have trained thousands of black belts. All the test marks are with me. All the marks available with me, and that is called population data. Am I correct? 1,000 students have undergone training with black belt. So 1,000 marks are with me. I visualize the mark. I plot a histogram. Now the distribution is called population distribution. Do you understand?
Yes.
Next, I want to understand how we performed so far. We have done several batches. I pick up one of the batch, maybe the 12th batch I pick up. Now, what is this 12th batch? 12th batch is a sample from the population. Am I right? Your performance I am visualizing. Why do I visualize your performance? By seeing your performance, I want to understand my population. Now I am an outsider. I don't know. Suppose you want to study my company's performance. You are not an insider. You are an outsider now. I may not give you the full data. Now what will you do? You will just see how the students are performing in this batch, and then you will make a judgment, on our commitments. Yes or no? You are trying to understand, the performance of all the students who joined our institution only by studying a sample. Now you are working with the data, which is a sample data, and when you visualize the sample data, the distribution is called a sample distribution. Do you understand the difference between population distribution and sample distribution? Yes.
Yes, sir.
Very good. Now, the batch 12, 15 people are there. 15 marks are there. Can I calculate average? Can I calculate average?
Yes.
Very good. So average mark of batch 12 students is available with me. Similarly, average mark of batch 11 student will be available with me. Average mark of batch 10 will be available with me. So every batch I have an average. Can I visualize the average alone? Possible?
Yes, sir.
That is called distribution of sample means. That is called what? Distribution of sample means. Otherwise called sampling distribution of means. How many of you understand the 3 different distributions here? What is the first distribution?
Population.
Second distribution?
Sample.
Third distribution?
Means. Sample means.
Distribution of sample mean. Each distribution can behave in a particular way. Am I correct?
Yes, sir.
What do you want to understand? You want to understand the population. You want to understand the population. Now, which one can better represent the population? Sample will better represent the population, or distribution of sample mean will better represent the population?
We believe it is sample, sir. Sample distribution.
Second one,
Yes, sir. We hope so. We don't know.
how about others? What is my population? All the black belts I produced over the last 1 year. Now, when you believe in sample, your sampling technique is cluster sampling. When you believe in sample average, your sampling technique is stratified sampling, which is powerful, which is having more power. You have 5 companies. You are doing audit in all the 5 places, which is stratified. You have 5 companies. You are doing audit in only 1 place, which is cluster, which is powerful.
Stratified.
So the third one is more powerful. So that is the reason why always you collect data in subgroups. Always you collect data in subgroup. You take multiple data, calculate the average, and you take your decision based on the average, not on the sample value, isn't it? Right? So what are these values? These are average. First subgroup average, second subgroup average, third subgroup average, and every subgroup average is visualized, right? And every distribution will have its own characteristics. Population characteristics are, when I write, it is normally distributed. When I write n, it is normally distributed. And the statistics of the population are mu and sigma. What is mu? The population average. What is sigma? Population standard deviation. How do I get population mean? Add all the data and divide by the number of units in your population. Mostly we don't know this. Most of the situation we don't know mu and sigma. Whenever you don't have clue about mu and sigma, your study is inferential, right? Then the sample, see, these are called parameters. The mu and sigma are called parameters. When you take sample, from the sample data, you can calculate average. Now average will be called X bar. Standard deviation will now be given the symbol capital S. These are again, statistics. These are simply called as statistics. But mu and sigma are called as parameters.
Sir, S will be coming or not, sir, in statistic?
S will be coming. S will be coming. Using sample statistics, we are trying to understand the population parameter. Using the behavior of the sample, we are trying to understand the behavior of the population. How a child behaves, we are trying to understand their parent behavior. Isn't it? So that is why we take sample. But your understanding can be much more clearer when you work with the third distribution. What is that? Distribution of sample means. Why? Because sample means have a close relationship or more relationship with your population parameters. I mean, the statistics of the distribution of sample mean will have more relationship with population parameter. How? When you take X, when you take the average of the averages, each one is average here, right? When you take average of the averages, now the central value of the third distribution will be X double bar. This X double bar will be more close to mu. That is what you want to understand.
Can you say it with confidence, sir, that X double bar will be more representing population mean?
Yes. Yes. Another thing. And now you can always calculate the standard deviation of the central values. Possible or not? 3 central values are there. If you calculate the standard deviation, that is called the standard deviation of the central values. The standard deviation of the central values are otherwise called as standard error of the mean. Right? So, when you take more sample, it is more likely that X double bar will approach mu. X double bar will approach mu. And then the SX bar, nothing but standard error of the mean, can be calculated using this formula. Standard deviation divided by root of n. What is standard deviation? The standard deviation that is there with you, whatever data you collected, the standard deviation divided by root n. What is n? Subgroup size. This standard error of mean will help you to locate the confidence interval. So far is clear to all of you. Am I right?
Sir, how do you read this one, sir? X is approximately, sir, normally distributed mu and sigma.
X is normally distributed. Right? I mean, your variable is normally distributed. Here also your variable is normally distributed. Here,
how do you read as a sentence?
You just know your variable is normally distributed with mean mu, standard deviation sigma. Right. And now I'm going to give one more important information. If my population is normal, it is very sure the distribution of sample means will definitely be normal. It may not happen with the second line. Do you get my point? When population is normal, if you still work with the samples, your sample may behave abnormal. So sample behavior will be erratic, and that will not help you to predict the population behavior. That is why you must prefer to work with the third one. When sample is normal, the distribution of sample average will definitely be normal. When when population is abnormal, then also the distribution of sample average can be normal. That is why by mastering normal distribution, you can handle any situation. When population is normal, you work with this. When population is abnormal, or maybe other distribution, gamma distribution, label distribution, Poisson distribution, whatever it is, then also the distribution of sample means will be normal. Clear? But your sample size should be large. But in the previous case, when population...
What is the definition of large, sir? How do you numerically say?
When population is normal, your sample size can be small. But when population becomes abnormal, in order to get normality in your data, your sample size should be sufficiently large. But what is that optimum value? Generally, when n equal to 30, people consider any sample more than 30 as large, any sample less than 30 as small. But that is not the perfect solution to the problem, right? If, for example, what is this distribution? This is an exponential distribution. When your distribution is exponential, is the distribution symmetric? No, it is not symmetric. It is not symmetric. In order to get your sampling mean distribution normal manner, you gradually increase your sample size. At a particular sample size, you will start getting the normality. That is the ideal sample size for you.
So we have to iterate.
You need to do some experimentation. Clear? So this is a more practical way, but formulas are there, right? And sometimes it may happen that your sample size should be equal to 50 or more to get this normality. This is how you arrive on the. So to be on the safe side, I say large. I'm not making any commitment on the thing. See here, my distribution is uniform. It is not normal. So now I will, how do I work? I will collect data in subgroup and visualize the average of the subgroup. That means what is the order of the distribution? Third distribution. Now this distribution can become normal even with the subgroup size of 50. So such a small sample helped me to exhibit the normality. The reason is my original distribution, the population distribution was symmetric at the center. Do you see here? Is it symmetric or not?
Symmetric.
Symmetric. And under such situation, even a smaller sample size, subgroup size can get you normality. Now your sample cost can be reduced to a great extent. Just you take 5 samples. Ask your team member to take 5 samples. Why you did it? Because the population is symmetrical in behavior. But when population is not symmetrical, in order to gain the normality, look at your sample size.
50.
Right? So that's how it is. And now, what is the central limit theorem here? The distribution of sample average will definitely follow normal distribution for any sample size if the population is also normally distributed. Do you understand my statement? The distribution of sample average will definitely follow normal distribution if the population is normal, and this is true for any sample size. But when population is not normal, in order to get my average distribution of means normal, my sample size have to be large. Central limit theorem also doesn't give you the sample number. That should come out of your intelligence. Clear? All right. Now another few minutes. And you all know who is this?
Sir, I have a question.
Yes, sir.
Sir, if, supposing in the Minitab, if we try to understand the population characteristics of the distribution, okay, so we plot it and then we come to know that it is non-normal. Okay,
Okay.
and then if you keep on doing the iteration for the sample distribution and also the sample means of the distribution, and then the plotting the curve, and then if you try to get the normality and then understanding the sample size, can you do it, sir, in minute time?
No, see what we are talking right now is a realistic situation. You
Sir.
need to really collect sample, collect data, and plot it in Minitab, and several iteration it will take. Several iteration it will take, and some point of time you will be able to get the normality, and then you can fix that number as the sample size for your further study. This is a researcher, you have to do it.
Minute time will help us, sir.
Yeah, it's possible. It's possible. And I think Mr. Vinod will teach you a session on Minitab, and we have scheduled it. I think next week we'll inform you the date. All of you can attend that. And now, why do you study that? You want certainty. You want to understand the certainty, isn't it?
Yeah.
Certainty becomes possible only when the distribution gets a particular shape. Let's say if it becomes normal, then you can make a lot of judgment. Otherwise, your judgment can
Have uncertainty
wrong because of the amount of uncertainty in it. So that's why we must prefer to work with the distribution of the sample averages. Yes, RK sir, you want to add something here? You are muted. You are muted.
You are asking a very big question. I will tell you, there is a very short answer for that. There is a theorem called central limit theorem, which I'm going to teach you so that you don't have to do any iteration in chemistry lab or iterations in the field, right? You don't have to do much of the experiments. Okay, you just have to decide what is the sample size, what are the experiments to be done, how many experiments to be done. How many experiments to be done is how many minimum number of experiments required. These things will be obtained in probably in DOE, or if you join a master black belt, right? You will understand all these things in master black belt, just like that. In black belt, you will understand probability. You will blame us. He has not taught us complete thing. He has taught us only a few, like that. Don't blame us, but we will certainly teach you, right? It takes time. That's all. Thank you.
Please,
All right, so let us move on. We also touched on the central limit theorem just before this slide. Anyway, he will re-explain. So now this is Virat Kohli, right? So you all know, and his performance over the last year is plotted here as a graphical summary is made available. His histogram, and using your eye as a tool. Do you find it normal? Your eye is the tool now. Is it looking like a bell?
yes, sir.
Your eye is very powerful, then you will be able to judge correctly, right? But otherwise, you may have to test your eye. So it all depends on the kind of tool we use, right? On the decision. So this is definitely, considered a normal distribution, and mean value is this much, standard deviation is this much. With this, so mean score of batting average of Virat Kohli is 60.15, and the standard deviation associated is 5.03. All right. Now, when Virat Kohli's batting average over the last few years is 60.16. What could be the expected batting average from Virat Kohli in the next 5 matches? Come on, if I ask you the question in real time, what could be your answer? So far, he is known for batting average of how much? 60.16. He is going to play another match, another tournament comprising of 5 matches. What could be your batting average? I have given the answer. You just have to say.
But Virat Kohli's current batting form, it will be less than 25.
No, that is a realistic one. This is hypothetical.
See, we
Current form.
are now going for an inferential statistics based on data available. So far, till the last match, his batting average is how much? 60.16. And now you are the selection committee. Will you select Virat Kohli when he maintains a batting average of 60.16?
Sir, we have to find out the sigma.
Yeah, sigma is also available, no problem. Sigma is 5.03.
Okay, sir. So
You select, right? Why are you so, you are doubting Virat Kohli is too much? Batting average is good, right?
sir,
Yeah. So you will definitely consider him for the next tournament. And now, why did you select it? Because you have some confidence on him. Am I right?
Yeah.
You are confident that he can maintain a batting average of between 58 and 62. Or you can even say, if you are not, or don't want to use the number, you can say you can expect a batting average of 55 and 65. Am I correct? These are nothing confidence limits.
Confidence.
These are nothing but confidence limits. What is making you to arrive on this number? One is the mean you observe. One is the mean you observe. The other one is the standard deviation. Right?
Yeah.
Now, what are you trying to predict? You are trying to predict the mean. You are again thinking about the average. Now, instead of using the standard deviation, use the standard error of the mean. You understand? Instead of using the standard deviation, use the standard error of the mean, because your prediction is again going to be on the average. What is the batting average you can expect in the next 5 matches? So this interval 58 to 62 is called confidence interval. Now what is the confidence interval? Very narrow. Narrower, isn't it? That means, he is very consistent player. That's why he is consistent player. He can see to that his average lies within a narrower interval. And how much confident you are in selecting Virat Kohli or recommending Virat Kohli, that is called your confidence level. All right? Fine. It is to be noted that normally data will cluster around the mean. Data will distribute equally about the mean. Look at your lower limit. Lower limit is 58. Look at your upper limit, 62. Look at the center value,
60.
It's again, around the average. Mostly your data will cluster around the center. Approximately half of your value will be on the left, half of your value on the left. This is what we learned in normal distribution. The same thing is what we are also talking. The left side interval is 2 runs, right side interval also 2 runs, right? So confidence interval depends on the standard error of the mean. What is how to calculate the confidence interval? What is the mean value so far? 60.157 plus or minus 1.96 into standard error of mean. What is this 1.96? Generally, we target a 95% confidence level. If you want 95% confidence level, what is the band you are talking about? You are talking about plus or minus 2 sigma from the center. Am I correct?
Yes.
When the 95% of the area will be covered, when you cover plus or minus 2 standard deviation from the center, what is the area inside? 95.45. If you make it to 95, the 2 will become 1.96. Do you now understand how the 1.96 coming? Plus or minus 1.96. Because I am aiming at a confidence level of 95%. When
So you are talking about a standard normal, right, sir? Standard normal distribution. Because you are talking about Z.
Yes, correct. Z.
Sigma is 1.
Now I'm talking about standard normal distribution. You are right. Very good. Suppose I want 99% confidence level.
3.
Very good. Beautiful. Your confidence level, when you improve, your confidence will become wider. Why it is becoming wider? Increasing the Z score. All right. So, but the beauty is, the requirement is confidence level have to be high. Confidence interval have to be narrower. Then only you will be appreciated on your decision. So if you want a narrower confidence interval, this portion, whatever plus or minus you are adding or subtracting, the portion which you are adding, the portion which you are subtracting is called the margin of error. Nothing but half of the confidence interval is called what? Margin of error.
That should be less, no, sir. That should be less, no? 1.96.
Your margin of error should be as low as possible. That will be possible. When you take more sample. When you take more sample, then only standard deviation will go down. Right? All right. Now, standard error of mean. Standard deviation divided by square root of n. What is the standard deviation? 5.032. What is the n used here? No, let us say the number of data is 25. Number of data, 25 matches, score is available, right? So, square root of 25. So, standard error is 1.01.
Here it's subgroup size. 25 is the subgroup size, right?
Yes, 25 is the subgroup size. Because, see, what is subgroup size? The number of data used to calculate the mean. 60.16 is an average of 25 performance of Virat Kohli. Now, subgroup size becomes 25. So, now confidence interval of the mean is 58.08, 62.96. Now do you understand how the confidence intervals are located or confidence limits are located? What is your level of confidence in this statement?
95.
How do you say 95?
1.96.
Beautiful.
This is, sir, actually in a normal distribution, we talk about specification limits. In standard normal, it becomes a confidence limit. Isn't it, sir?
Perfect. Very good. Understanding is so good. So our accuracy of our findings, accuracy of our inference, accuracy of our conclusions depends on the variation in the data. We make conclusion using the average. Conclusion will sound good if the variation is low, right? And now, so accuracy of inference is a function of variation. And now, as far as the confidence interval is concerned, we are talking about the mean, right? So it becomes a function of standard error of the mean. Lower the error, narrower will be the confidence interval. Narrower the confidence interval, conclusion will be more accurate, more realistic, more meaningful. Hope it was helpful to all of you. And now one last scenario. I have some scores 58, 62, 56, 61, 25, 40. These are three different batsmen. The first confidence interval corresponds to Virat Kohli. The second confidence interval corresponds to Rohit Sharma. Third confidence interval corresponds to Jadeja. Now you have to select the two people. Tell me whom you will select.
Virat and Rohit.
First two.
Very simple decision. All of you will take the same decision. You know why you have selected Virat and Rohit? You are very sure the difference in performance of Virat and Rohit compared to Jadeja is significantly higher. You can use the word significantly higher, but when your confidence interval do not overlap. How many of you understand the statement? Otherwise, you only say there is a difference. You can use the word significant only when your confidence interval do not overlap. Rohit confidence interval is here. Sorry, Virat. And this is Rohit. And Jadeja's confidence interval is here. Is there any overlapping? No overlapping, isn't it? You can definitely say Virat and Rohit performance are significantly better than Jadeja, and so these two can be included in the team. Jadeja can be excluded from the team. Your decision is perfectly all right. Suppose if you have to select only one person, now tell me whom you will select.
Virat.
First one.
But I don't appoint you as a coach for the team. You are not able to decide correctly. You know why?
Because it's overlapping.
It is overlapping. You are not seeing, you are not taking the decision with an unbiased way. As a coach, as a leader, you should be unbiased. If you say Virat is good, and how much is Virat is better than Rohit? How much he is better? What is his average? 60.0 or 60.9. What is his average? 60.7. What difference you have seen? It is very likely that even Rohit can play better than Virat in the next match. Can it happen or not? That chance is there or not?
Yes.
That chance is more, but still you want to support Virat. That means, you are favoring.
You are biased.
I don't know you are dealing with Virat. Isn't it? So I will not, make a choice between Virat and Rohit if I want to be unbiased. I will say both the same. Maybe I will just toss a coin and select, but I will not favor Virat and Rohit. Whenever your confidence interval overlaps, don't consider the difference as a difference. The difference is insignificant to differentiate the performance. Is that clear? Yes. Conclusion one, Virat performance is better than Jadeja. Yes, your decision is statistically significant. Your decision is statistically correct. Rohit performance is better than Jadeja. Yes, again you are statistically significant. The difference is statistically significant. Your conclusion is a meaningful conclusion. Third conclusion, Virat performance is better than Rohit. If you write a thesis like this, based on the data you have, with the confidence interval like this, your thesis is invalid. Because there is a difference. The difference is insignificant. Don't believe everything you see, isn't it? We are not supposed to believe everything we are seeing. The data driven is good. but data can also sometimes mislead. Whatever you observe, maybe a random chance. For everything there is a chance, isn't it? So you need to, random chance means uncertainty. Don't make your decision get affected by the uncertainty. Uncertainty should be as low as possible. And that is what you are ensuring with the first two. But the same is more uncertainty, in your decision. Going wrong is more with respect to the comparison between Virat and Rohit. And so I don't consider the study as significant. I don't consider the difference as significant. Rather, I will continue with both Virat and Rohit, or I will try to extend the period of study to make a conclusion. So we should conclude only when the difference is statistically significant. In all other situations, we'll simply keep quiet. We'll not take any decision. Is that clear? So difference is statistically considered significant if the confidence interval is located by adding or subtracting the margin of error. So what is margin of error? Half of the confidence interval. Alternatively, another beautiful tool is p-value. Use the tool p-value, and then you can still, because in order to make you understand all these things, I took a considerable amount of time, isn't it? Instead of that, simply calculate the p-value. When your p-value is less than 5%, consider the study as significant. Consider the difference as significant. When p-value is more than 5%, consider the difference as insignificant. Very simple decision. So what is p-value? That will be taught to you in the analyze phase. So there are two types of error possible: type 1 error and type 2 error in any statistics. This error can be result of measurement or can be result of sampling, right? So it can be caused due to poor measurement system. That's why we taught you MSA. It can be caused due to poor sample collection. That is sampling error. That also taught to you. And measurement error we study by using these tools: bias, linearity, stability, AJR study, and one more thing, attribute agreement analysis. And the measurement error need to be less than 10%, right? And sampling error need to be less than 5%, right? Generally. And in sampling error also, see, in both cases, the error, because of both measurement as well as sampling, you may cause type 1 error and type 2 error. Type 1 error and type 2 error in sampling are called alpha and beta. Where alpha is level of significance, which is type 1 error. Beta is the consumer risk, which is otherwise called type 2 error. They are also called as false positive and false negative. Alpha is false positive and beta is false negative. The false positive, false negative terms are used mostly in medical world, right? If the insignificance is concluded as significant, like you are favoring Virat, you are committing type 1 error, right? When significance is concluded as insignificance, Virat is better than Jadeja, but still you are saying that there is no difference. That is called what? Type 2 error. Maybe a little confusing. Please watch this video, go through the literatures. You will definitely be able to appreciate. So ability of your study to correctly accept the insignificance, right, is called confidence level. Maybe again difficult. The ability of your study to correctly accept the insignificance is called the confidence level. And the ability of your study to correctly detect the significance is called the power of test. Both are important, right? And 1 minus alpha is confidence level, 1 minus beta is power of test. And then data worthiness, I already talked to you. So data is considered worthy if the measurement error is limited to 10%. If the sampling error is limited to 5%. What is sampling error? Both type 1 and type 2 error. Right? Type 1 error due to uncertainty in sampling must be limited to 5% so that you can achieve 95% confidence level. Type 2 error due to uncertainty in sampling must be limited to 5% to achieve 95% power of test. So this completes. And also please note your sample size, type 1 error, sample size, confidence level, power of test, and the difference in the statistics you want to validate. Jadeja and Rohit, the difference is too high. Even with lesser sample, you can conclude. But between Rohit and Jadeja, the data is insufficient. That is what we are trying to judge. And that's it. This is what I wanted to talk to you about the basic statistics. Hope it was helpful to all of you. So any questions? RK sir, you can stop recording. RK sir, are you?